Hello all, I'm Dr. Pravas Sanjanwal. In today's class, we'll discuss about Rice theorem for undecidability. Okay, so actually in this class, particularly we'll discuss about how to design the language corresponding the given problem, and the given language is Arial or not, This is our main discussion for the today's class. Okay, so say these are all the problems. These are all problems. So what does the given Arial is regular or not? Okay, these problems are decidable or undecidable. We have already discussed two to three classes in the previous classes. Okay, and how to apply Rice theorem on the given problem. How to apply the Rice theorem on the given problem, and after applying the Rice theorem, then we can say that what the problem is decidable, the problem is undecidable or not. This is the not decidable. We cannot say about the decidability, but here we can say that what this problem is undecidable or not. Okay, by applying the Rice theorem. Okay, so this is the given problem. Does the given RL is regular or not? Does the given RL is regular or not? See here. This is my domain part. This is my range part. 0, 1. Okay. So this is the what set of RL. Domain contains what? Set of RL. Set of RL means it contains some of the languages. Let it contains languages like L1, L2, L3, like this, some of the languages. Some of the languages may be regular. So let L2 and L3 both are regular. So it will map with 1. Okay, some of the languages. Let L1 is also regular, so it will map with 1. Some other languages like some L, suppose 100, it will map with 0. And L100 is not regular. Okay, so that means we can see here this portion. This is every regular language is RL, but every RL need not be regular. Okay, so some of regular languages means in this, just see this Venn diagram. In this diagram, some of the languages will map with what? 1. That means this is called as which property? Non-trivial property. Since it is a non-trivial property, so this problem is called as undecidable. Okay, this problem is called as undecidable. Okay, but here in today's class we will mainly discuss how to find out the language corresponding to the given problem, and then we'll decide this language is RL or not. Okay, so here some of the languages are what? Regular. Since some of the languages are regular, for example, like so L is what? L1, L2, L3, like this. Okay, so L, that means here L1 is irregular, L2 is irregular, L3 is regular, means some of the languages are what? Regular. Since some of the languages are regular, this is the means language L is the what? Collection of all languages. Language L, important point here, just say language L equals to what? L1, L2, L3 up to some of the languages, means some infinity languages. These languages are what? Regular. Regular means it will map with 1. Now we'll collect here L1, L2, L3 like this. Here you see L means what? Language. Just see the definition. Just see this definition. What? L means language is the what? Collection of languages. Language is the collection of languages. It is wrong. Language means what is the actual definition of language? Language is the what? Collection of strings. Language. Language L means what? Collection of strings. Collection of strings. Language means what is the definition of language? Language is the what? Collection of strings. But here, according to this Venn diagram, language is the what? Collection of language. So this is wrong. So how to convert this definition into the actual definition? Means the language is the collection of strings. How to convert? Just see. L1, here L1 is what? Regular. L1 is regular. Since L1 is regular, every regular language is what? Real. Okay. So this L1 is what? Real. This L1 is what? Real. L2. L2 is what? Regular. Since L2 is regular, every regular is called as real. So here L2 is also real. L3. Here L3 is what? L3 is regular. Every regular is called as real. So L3 is also real. Okay. So that means L1 is real, L2 is real, L3 is real, and some of the infinite languages all are also regular. Sorry, real language. Since L1 is real, we can also construct Turing machine. Let it is TM1. Here L2 is real, we can also construct Turing machine. Let TM2. Here I'm just writing M1, M2. I'm just writing here M1, M2 machine. Okay. Since L3 is a real language, so we can also construct Turing machine for L3 language. Let it is M3. Similarly, we can construct Turing machine for all languages. Okay. Since M1 is a Turing machine, we can also convert this Turing machine into binary encoding form. Let binary encoding form. Let it is 101. Since L2, we can construct Turing machine for L2. Turing machine for L2 language like M2. We can also construct convert this M2 into binary encoding forms. Let it is 1101 like this. Similarly, we can also construct the binary encoding forms from M3 to let it is 0011 like this. Okay. So this is what? This is string. So finally, language is the what? Collection of strings. Means we just convert the given language. Into binary encoding forms. Binary encoding forms, indirectly it is called as what? Strings. What is the definition of language? Language is the what? Collection of strings. Here we just convert. The language is means what? Language is a collection of, indirectly it is string. Okay. So now we'll write the language for the corresponding problem. How to write? Just say. But it does the given real is regular. How to write? Just say language L equals to M such that L of M is regular. L of M is regular. Okay. So what is the meaning? Just say. What is the M? M means this one. This is a Turing machine. M means this is the Turing machine. I'm just explaining what. This is M, this is LM. L means language corresponding the machine. Machine means Turing machine here. Language corresponding the machine is regular. So see. Here M1, that means here we'll write what? M means M1. M1, the corresponding corresponding language for the given machine. Corresponding language for M1 is what? L1. So L1 is regular for the corresponding machine M1. This is the point. So similarly, we can say that here let M means M2, M means M2. The corresponding language L2 for M2 is regular. Similarly, the corresponding language L3 for the corresponding, sorry, the not corresponding, the language L3 for the corresponding machine M3 is regular, like this. Okay. So this is the what? This is the language for the corresponding given for the given problem. Okay. Now we'll decide this language. Now we'll decide this given language. Now we'll decide the language means the corresponding language is Arial or not. How to decide Arial or not? Later we'll decide. First we'll design the language for all problems. Then we'll decide. Okay. So similarly, here we'll design the language. Does the given Turing machine accept finite language? Just say, does the given Turing machine? We have already discussed these types of problems in the previous classes. Okay. Does the given Turing machine accept which language? Turing machine accept Arial language. Turing machine accept Arial language. Okay. Does the given Arial finite language? How to design the language? Language L equals to M such that L M is finite. It is very simple. It is very simple. Okay. So similarly, the third problem, does the given type 0 grammar generate string of length 2023? See, type 0 grammar generate which type 0 grammar generate which language? Arial language. Does the given Arial of string of length 2023? How to design the language? Language L M such that L of M means cardinality of L of M. What cardinality of M means? Length of the language is equals to 2023. Okay. The machine such that cardinality of LM is equals to what? 2023. Okay. Does the given Arial empty? So how to design? Just say language L. This is the machine L of M such that what? Sorry, language corresponding language L of M is empty, means is fire. We can write like this, or we can write, let's see, M. We can also write length. Here we can mention cardinality of LM equals to 5 or not, means length we can say, but we can also write like this, L of M is empty. Okay. Does the given Arial complete? L equals to M such that L of M equals to sigma star complete. Or also we can write like this, L equals to, sorry, M, L of M is complete. Okay. A sixth problem, the last problem. Does the given RL contains string of length even? So the language L, this is M, L of M, but string of length even means L of M mod 2 equals to 0. Okay, mod of 2 equals to 0. Okay, so here problem is given, we can just convert, means the problem into language. Now we'll decide the language is real or not. How to decide? Just say the important note here. If the property P is non-trivial, then LP means what? Language corresponding property. LP means what? The language corresponding property is not REC. Not REC means what? Just say, if the property P is non-trivial, we have already proved. Just say, if the property means, or we can say problem, if the given problem is non-trivial, then this problem is called as what? Undecidable. Then the problem is called as undecidable. Then the corresponding language, the given property or problem, then the corresponding language is what? This one is the corresponding language, is what? Not REC. Means the given language is not REC. Not REC means not recursive. Not REC means what? Not recursive. Not recursive means it is called as what? REL language, means recursive enumerable language. Okay, so again I explain here. Does the given, if the given problem P or given property P is non-trivial, means the given problem is following non-trivial property, then the corresponding language is what? L equals to M, such that LM mod 2 equals to 0. The corresponding language is what? Not REC. Not REC means not recursive. Not recursive means it is called as what? REL language. REL means recursive enumerable language. In this way, we can prove that the given language is what? REL language, and the given language is called as what? REL language. Sorry, this is not REC, REL. Okay, and similarly this problem, it will follow which property? Non-trivial property. The corresponding language, this is the corresponding language. This corresponding language is not REC. Not REC means this is REL language, and this language is what? REL language. Similarly, the above language means this one is called as REL language. Okay, in this way we can prove that the given language is REL or not. Okay, if the problem is given, we can construct or we can design the corresponding language, and if the problem is following, if any problem is given and the problem is following non-trivial property using Rice theorem, then we can find out the corresponding language, and we can say that the corresponding language is not REC, means not recursive, and it is also REL. Okay, so in the next class we'll discuss one more new concept. And okay, thanks for watching.